Hello and welcome to Cannon County High School Algebra 2. Today we are going to talk a little bit about a statistic called variance. And variance is something that measures how spread out the data is. The next 2 days we're going to be talking about several statistics that talk about how spread out the data is. And variance uses a letter that you may not be familiar with. You're familiar with the letter, but you're familiar with the uppercase letter. You know that sigma, I'm going to draw it right here. We talked about sigma as meaning that's the sum. You add things up whenever you see the Greek letter sigma. This is also sigma, it's just lowercase. Just like in, this is an uppercase V and a lowercase a. Well, this is an uppercase sigma and a lowercase sigma. Variance is lowercase sigma squared. Okay, that's the way you see it. So, Lion, as always, I'm going to ask you to supervise us from over there. And let's talk about what variance is. I'm going to zoom in just a hair here. Variance is sigma squared, and it's defined as the average of the squared distances from the mean. Now, that sounds complicated, but really, in a little bit more plain English, it measures how far a data set is spread out. Today we're going to talk about variance because you need to understand variance before you talk about standard deviation. Most people actually use standard deviation more often, but you have to understand variance first, and so that's what we're doing today. We're going to split it up into 2 days just to make it a little bit easier. The formula that you use for variance is sigma squared is equal to, and there is the capital sigma, I just wrote that up on there to show you that we're adding up all of the squared distances from the mean, k minus the expected value. Yesterday we did expected value, so that's where that comes in. So k minus expected value is the distance from the mean. We're going to square that, multiply it by the probability, and then add them all up. I know, sounds complicated. It's not that bad. Here's what it looks like graphically, I guess. A lot of the populations that we're going to be studying form what's called a bell curve, and you've probably seen bell curves before in science and that kind of thing. Most things in nature follow a bell curve. That just means, let's say I was going to graph the height of everyone in class. Some people in class would be very short, some people in class would be very tall, and most of the people in class would be in the middle somewhere. So there's more people that are of average height, there are less people that are really tall, and there are less people that are really short. And most populations follow some kind of bell curve that way. So the mean is the number that's in the middle, right? That's the average. So what we're doing when we find the variance is you take some value, k, okay, this is like you. You're a little bit taller than average. You're not the tallest person in class, but you're taller than average. How far are you from the mean? Well, that would be k minus the expected value. It would be your height minus what the average height is in class. To figure out how spread apart the data is, we would plug it into this formula. We would take that, square it, times the probability, and then add all those up, and that gives us this statistic called variance. And what variance allows you to do is tell how spread out the data is. So for instance, let's say the data looked like this, okay? Went up and down very steeply. Well, then the variance would be small. What if the bell curve looked like this? Well, if the bell curve looked like this, well then the spread is much larger. So what the variance allows you to do is statistically tell how spread out is the data without actually having to graph all the data. Okay? So now that we know kind of what it is, let's actually calculate one. Okay? So here's our formula again. I wrote that up here. And this is, let's see, this is DD5. So I'm going to write that over here. If you want to try a couple of these, DD5 on the IXL is where you're going to go to find these. But they're going to give you a probability distribution, kind of like what you're used to, where they're telling you what X is, and they're telling you what the probability of each of these is. Okay? And so what we're going to do is we're going to calculate the variance using this formula. The first thing that we have to find is the expected value. So this is what we did yesterday. And so step one, I'm gonna put step one here, find the expected value. So let's do that first. Just like yesterday, we're gonna put another part to this table, and we're gonna take x times the probability of x, and when we add all those up, that'll give us the expected value. So let's do that. When you take 3 times 0.6, you get 1.8. When you take 4 times 0.2, you get 0.8. When you take 5 times 0.2, you get 1. And when you take 6 times 0, you get 0. And you know that the expected value is just when you add all these up. So when I take 1.8 plus 0.8 plus 1 plus 0, that gives me an expected value of 3.6. So now I know what the expected value is. The expected value is 3.6. That's like the mean or the average of this set of data. So just think about that for a minute. You've got 3s, 4s, 5s, and 6s. If I were to draw this on a graph, since the probability of getting a 3 is 0.6, the probability of getting a 6 is 0.0, this graph is kind of skewed over to the left. And it would make sense that the average is smaller. If this was just the average of 3, 4, 5, and 6, then the average would be 4.5. But since the probability of getting this lower number is higher, that means the average is going to be a little bit less. So the first step is to find that. Okay. Step 2 is to find the variance. Okay. In order to do that, in our formula, we have to figure out what k minus the expected value squared is equal to. Okay. So I'm going to extend this again, and I'm going to put that on here. I'm going to use x instead of k. X minus the expected value, and then I'm going to square that. So let's figure out what that's equal to. All right, let's see. And I've done this already, so I'm just going to write the numbers down. But what you can do is just do it on your calculator. So x is 3. So on your calculator, take 3 minus 3.6. We could probably do this one in our heads. What's 3 minus 3.6? 3 minus 3.6 is negative 0.6. What's negative 0.6 squared? Well, that would be positive, right? Negative times negative is positive 0.36. So this number right here is positive 0.36. Okay, let's do that with the next one. Remember, this is the e of x that we're using all the time, the expected value. What's 4 minus 3.6? 4 minus 3.6 is 0.4. If you were to square 0.4, you would get 0.16. So 0.16 goes right here. And you just keep going. 5 minus 3.6 would be 1.4. 1.4 squared is 1.96. 6 minus 3.6 would be 2.4. 2.4 squared is 5.76. Okay? I'm not going to bore you with bringing in the calculator and typing all that in because you can do that yourself. So now we've actually calculated what each of these values is. Okay? Now all I have to do is multiply, so that's what it says to do in the formula, multiply each of those by the probability. So this one is going to be x minus the expected value of x, quantity squared, times the probability of x. That's what we're doing here. And then after we get these numbers, we just add them together, and that's the variance, because that's what the sum means. We're just going to add together whatever we get here. So now we're taking this column right here and multiplying it by the probability over there. So in other words, what's 0.36 times 0.6? It's 0.216. Try it on your calculator. Again, I'm just taking this times this. So what's 0.16 times 0.2? It's 0.032. What's 1.96 times 0.2? it's 0.392. And what's 5.76 times 0? It's 0. Okay? So, in other words, this whole column is just this column times this column. And once you've got that, remember, we're just adding those up. So you add up these four numbers. So that means that the variance, write it down here, the variance is going to equal 0.216 plus 0.032 plus 0.392 plus 0. So the variance is going to equal 0.64. And that is what we were shooting for all along. That is the variance. That's how you calculate it. Okay? It takes a little bit of work. You got to actually, make a table. You're going to start out, remember what we started with. We just started out with these two columns. But then you're going to construct these three columns to help you calculate the variance. This column is when you take x times p of x. Okay? This is the one that takes probably the most work of figuring out. You take this number minus the expected value, and then square it, and that gives you this. And then finally, for this column, you take this times this. Okay? So again, this is DD.5. I wouldn't say you have to do a whole lot of these. You don't have to get this one up to 80%. If you just do 2 or 3 of them, I think you'll get the idea. And here's the other thing. It's very good to understand how to calculate the variance. But you can imagine that eventually what we're going to be doing is plugging these into our calculator, and the calculator will be able to calculate variance for us. But just like anything else, it's really good to understand how a calculation happens before you start using the calculator obviously we can eventually program our calculator where if we type these into it, it can do all these calculations for us automatically. But it's really good to understand where that's coming from. So try a couple of them. Just try 1 or 2 on DD.5 and see if you can get the correct variance. And that will help us for what we're going to do tomorrow. Because tomorrow we're going to be talking about standard deviation, which is something that even people who don't know a lot about probability and statistics know about standard deviation and know that they have to use standard deviation in lots of applications. Okay? So if you have any questions, put them down in the comments. If not, I will talk to you tomorrow. Thank you for watching. Bye.